Hello, class. Today I'm here to present a pathogenic strain of Yersinia that is also known as the causative agent of the plague, which claimed millions of innocent lives, and that's none other than Yersinia pestis. The goal of this presentation is to understand the history behind Yersinia pestis, its morphology and characteristics, modes of transmission in regards to how it's transmitted from point A to point B, its medical importance as far as what forms the plague may take on, and lastly, signs, symptoms, prognosis as far as mortality rates, diagnosis, and treatment. Before its ultimate discovery in the late 19th century, there were three notable occurrences of the plague that ravaged and claimed millions of innocent lives. The first documented pandemic was also known as the Plague of Justinian, which ravaged through modern-day Istanbul, Turkey in 541 AD. According to modern-day estimates, millions of people passed away and lost their lives before the disease eventually subsided in the 700s. A lot of people during this time felt as if it was a message from God punishing the people of Earth for their sinful behaviors. The second notable occurrence happened in the early to mid 14th century between the Mongolian Empire and the Genesee. And a lot of historical experts believe that the disease spread to numerous amount of people after the Battle of Kaffa. And ultimately, this would lead to the Black Death in Europe due to trading imports that landed in Sicily. And in the Black Death, millions of people lost their life, and nearly a third of the population of Europe was eliminated before it would subside about 2 centuries after the whole plague itself, which is an amazing statistic, but also horrible at the same time. Fast forward to the late 19th century, and we're met with a person who actually discovered the causative agent of the plague, and his name was none other than Alexandre Yersin. He was a Swiss-French physician who joined the Institut Pasteur at age 22 in France. And this organization is very notable as its other many famous physicians discovered other infectious viruses and diseases such as HIV, AIDS, and Yersin also worked under famous physician Emile Roux, and with both of their workings and findings, they were able to discover the diphtheria toxin. As mentioned before, Yersin was appointed by the French government in the late 19th century to discover the causative agent of the plague that was already ravaging through China and had already claimed thousands of lives. On June 5th, 1894, Yersin and his team made it to Hong Kong, China, and began their mission. After only 15 days of workings, Yersin was able to discover the bacterium, the causative agent of the plague, through culturing and isolation. This was huge for medical personnel as now they know the causative agent of the plague, and now they can take the necessary steps to understand it for proper diagnosis and preventative treatments. Yersin would go on to do many other great things before ultimately passing away at the age of 79 in Nha Trang, Vietnam. A couple of decades later, after that, the bacterium was named after him, hence the name Yersinia pestis. And as I mentioned before, medical personnel still thrive off of his findings because now they understand the bacterium's characteristics and now know how to properly diagnose and provide the right preventative treatments. Now that we understand the causative agent of the plague, it's important to talk about its morphology and characteristics. Yersinia pestis is an encapsulated gram-negative coccobacilli that is non-motile and a facultative and aerobe. It has physiological characteristics as far as being able to ferment certain carbohydrates such as glucose, mannitol, and trehalose, but does not have an affinity for citrate to thrive and grow off of. Its most demonizing characteristics are its virulence factors, as far as containing capsular proteins that prevent phagocytosis from certain white blood cells, such as macrophages. It can also form endotoxins that can compromise live human cells, and it is coagulase positive, which is the most worrisome characteristic as it can clot blood. And for a certain form of the plague, this will really come into play and really set in motion how dire these types of characteristics are. There are some other characteristics that are important in understanding Yersinia pestis as far as its optimal temperature for 28 degrees Celsius. This helps to distinguish it from other bacterium in its family, as in most of those other bacterium have an optimal temperature of 37 degrees Celsius. Yersinia pestis can also live in pH extremes that reach basic levels anywhere between 5 and 9. And while Yersinia pestis does pack a virulent punch, it can die from other factors at a rapid rate as far as sunlight exposure or temperatures that exceed 40 degrees Celsius. According to professional bacteriologists and microbiologists, Yersinia pestis seems to originate in the domestic black rat or the brown sewer rat. And through these environmental factors that the rats live in, they will come into contact with the ultimate vector, which is known as the Oriental rat flea. Now, since I mentioned earlier that Yersinia pestis is coagulase positive, when that infected blood gets into the rat flea, it starts to coagulate the blood inside of its system, which blocks its GI tract. So with every bite from the flea, it regurgitates some of that infected blood back into the bite wound of its next victim or its next host. And this can be on domesticated pets such as cats or dogs, and that can be another way of it transporting to humans, as far as humans that are very close with their pets and the fleas that may come off of them, or even the infectious behavior or characteristics of the animal that is expressed may spread to humans, or the flea itself might directly bite the humans. Ultimately, no matter which two ways of transmission it might get to the human, it ends with the human being bedridden and ultimately very sick from a disease at a time before antibiotics had no answer for. As mentioned before in this presentation a couple of times, the plague itself can take on three different forms, such as bubonic plague, septicemic plague, and pneumonic plague. The most common form of the plague is known as the bubonic plague, in which the bacterium infects the lymphatic system and resides in lymph nodes, especially in the axillary, cephalic, and cervical regions. These can give rise to swollen, painful lymph nodes known as buboes, hence the name bubonic plague. And for most patients, it's impossible for them to move due to so much pain from the swollen lymph nodes. The second type of plague is known as the septicemic plague, and in my opinion is the most dangerous because, since I mentioned before that the bacterium is coagulase positive, when this enters your circulatory system, it is very important to receive a rapid diagnosis and a rapid preventative treatment, because these bacterium can coagulate the blood and cut off flow to certain organs or even the heart, which can cause multiple failure and ultimately death if not treated right away. The last notable type of plague is known as the pneumonic plague, and this plague is the only type of plague that can be transmitted from humans to humans through aerosol inhalation or respiratory droplets, because this plague infects the lungs and the whole respiratory system. When it comes to signs and symptoms of Yersinia pestis infection, these three different forms of plague actually share commonalities in their symptoms as far as nausea, vomiting, fever, chills, fatigue, but there are some distinctions between each plague that are able to differentiate it. As I mentioned before, in bubonic plague, the most commonly known symptom is bubo formation, which is swollen lymph nodes in the lymphatic system. For septicemic plague, you might have some bleeding into the skin or organs, and also necrosis, hence the name Black Death around the time in Europe, where a lot of people were dying due to live tissue death. In a pneumonic plague, it can give rise to pneumonia or bloody cough or watery cough. And honestly, when I was searching up these symptoms and these pictures, that was honest. That was my honest reaction. It was a very horrible disease that causes very painful symptoms. Before the antibiotic era, a lot of Yersinia pestis infections were decided with the flip of a coin. A lot of people didn't know the causative agent of this plague, and a lot of the times it was just supportive care and just prayer. But now, with the use of antibiotics, mortality rates have fallen as low as 10 to 11%, with septicemic and pneumonic forms still being highly dangerous and should be still rapidly diagnosed and rapidly treated because of its infectious pathways. Um, of course, in untreated cases, death is almost the definitive answer. There's no way that a human can be able to get through this plague without treatment. Unless there's some sort of miracle, some sort of medical breakthrough to where the human is able to fight this off alone. Usually, the intervention of antibiotics and certain treatments are key in order to prevent septicemic and pneumonic forms reaching dire levels as far as near death levels. But for the most part, antibiotics have played a huge factor in lowering the mortality rates of all forms of plague. Diagnosing Yersinia pestis infection depends on the type of form of plague that the patient may have or may be enduring. If you're dealing with a bubonic plague, doctors may use needle aspiration to take some of sample of the swollen, painful lymph node from the patient. Or for septicemic plague, since the infection is already present in the circulatory system, a blood draw might be commenced in order to understand what's contained in the blood. For pneumonic forms of the plague, an endoscopy is performed to look in through the respiratory tract as far as the nasopharynx, the trachea, and ultimately the lungs. All of these samples are taken and are cultured, or now with modern day technology will be ran through PCR analysis in order to confirm or compare the genes of Yersinia pestis to be able to properly diagnose. When it comes to treatments, it's important to talk about medieval versus Western medicine treatments. Before the creation of antibiotics, doctors would engage in animal cures such as depulking a chicken and attaching it to a sick patient. And if over time the chicken started to express those same symptoms of the plague, doctors believed that it was the disease was diffusing from the patient into the chicken, not realizing that nothing was being done and that actually the patient just infected the chicken as well. There was religious cures such as prayer, there was potions, fumigations, and bloodletting. And bloodletting was very notable as doctors back then would make an incision into the patient's arm and drain blood that they felt was infectious. And through this process, they felt that the infectious blood was being drained out, therefore minimizing the infection in the bloodstream and therefore curing the patient. There was a lot of evacuations of infected areas, and there was the rapid persecution of certain socioeconomic groups as far as the poor people with that stigma that rich people may back then have had on them as far as looking at the poor and just assuming that they're dirty and that they are not sanitary and don't know how to take care of themselves. So there was a lot of stereotypes, a lot of stigma, and a lot of persecution of maybe innocent people. Um, but now in the post-antibiotic era, now we have certain antibiotics that are treated in order to lyse the bacterial cells that Yersinia pestis might contain. Um, and I would say for most that I am glad to be living in a post-antibiotic era now where there's no stigma, and now that we all understand that anybody's susceptible of this disease, no matter the socioeconomic status. After going over Yersinia pestis' large history through thousands of years of killing and taking millions of innocent lives, the burning question that still arises to this present day is, why is Yersinia pestis still important? Yersinia pestis is still important because, like other bacterial cells, over time they might start to develop some type of antibiotic resistance. Now, there hasn't been any research or findings that support the fact that Yersinia pestis is starting to show characteristics of antibiotic resistance, which is very good for us, but it's important to understand that we can't just ignore it or we just can't not pay any mind to it because there is still that potential, there is still that possibility, but for right now, all we need to really be worried about is the evil reasons why Yersinia pestis is still important, and that's bioterrorism agents. According to the CDC, Yersinia pestis is in a long column of other bacterial cells that have the potential to be used as a massive bioterrorism agent. And it's very as simple as someone putting this infectious disease or these infectious cells and putting them into some sort of gas chamber or gas bomb and releasing it in front of a crowd of a lot of people, in which can be the rise and start of another pandemic and would still claim many lives regardless of the preventative treatments that we have today. Throughout this presentation, we learned a lot of important things about Yersinia pestis as far as its history, discovery, characteristics, medical importance as far as the forms it takes on, its diagnoses, prognoses, and even treatment options. With all that being said, I think it's very important to understand the significance of this bacterium and how serious it was. At a point in time before the creation of antibiotics, it did claim millions of lives and nearly made a whole continent go extinct. So with all that being said, I hope you guys took something out of this. I hope you guys enjoyed this presentation. Thank you for your time, and I hope you guys all have a good day.